Okay, this is going to be a short lecture on dew and frost points and different types of frosts. Two quick reminders of what vapor pressure is and what saturation vapor pressure is. So first, vapor pressure. This is the pressure exerted by water molecules in a given volume of the atmosphere. Whereas saturation vapor pressure, this means that the vapor pressure at a given temperature for which the number of molecules leaving a liquid or an ice surface is going to equal the same number of molecules entering that liquid or ice. So it's at an equilibrium. Okay, so if the vapor pressure is greater than the saturation vapor pressure, then that would make relative humidity greater than 100%. But this is impossible. Relative humidity can only be from 0 to 100%. Since it's not possible, water will condense to make dew. We can form dew in two ways. We can form dew if water is being added to the air, or if the air cools down. If the air is cooling down, then it can't, quote-unquote, hold as much water vapor. So now the term dew point, which is a term you might be more familiar with, dew point is the temperature at which air must be cooled down in order to become saturated without, this should be down here, changing the pressure. Okay, the closer the air temperature is to the dew point, the closer it is to saturation. So if there is a 50-degree difference between the air temperature and the dew point temperature, the relative humidity is going to be very, very low. If there's only 1 degree difference between the air temperature and the dew point temperature, it's going to be extremely close to 100% relative humidity. So to compare this, we get what's called the dew point depression. This is the temperature difference between the air and the dew point. The bigger the depression is, the bigger the difference is between the air temperature and the dew point temperature. Therefore, relative humidity will be relatively low. Frost point is going to work the same way as dew point. The only difference is that the temperatures are going to be below freezing. Therefore, we're going to get frost instead of dew, but the same process happens. Another difference between frost and dew is going to form through condensation, whereas frost is going to form through deposition. This is a little bit different than frozen dew. With frozen dew, you have water vapor condensing into liquid dew, and then that liquid dew then freezes. Where frost just goes right from gas to a solid via deposition. Here's two examples of some interesting types of frost. The first one is rime. This is formed by the rapid freezing of water drops from fog as they collide with an object at or below freezing. So this is mainly coming from a cloud that's low to the ground, which is called fog. As this rime continues to form, little air bubbles are going to get built up and trapped inside it. So this is going to give it a more of a white or opaque kind of look in which light cannot pass through. The next one's a hoarfrost. This is tiny ice crystals that form by the same process that dew forms, but when the temperatures of the surface or whatever it comes in contact, whether it be blades of grass or a fence, whatever the object is, the object's temperature is going to be below freezing point. This gives it a sort of a feathery kind of a look, and it will also form shapes in downwind. So if there's wind blowing, it's going to form these elongated shapes downwind.
This video shot by Ted Overbay, and look at that. We have the ice on the trees, the freezing fog, and then you have the precipitation, the fog. And essentially this process happens all the time in the clouds, but in this instance, the cloud was right here on the ground. But there you go, that's called rime ice, which we see a lot of in the mountains. Beautiful, beautiful, picturesque. Kind of slippery though, driving on there this morning.
Hello, I'm Vince Candela, Chief Meteorologist with Fox 6. Thanks for checking in with my video weather notebook. It's Sunday afternoon, January 17th. The past couple of mornings, we have had a beautiful example of hoarfrost. We've had freezing fog, and that has coated the entire landscape with a frosty white. Here's the situation. We have an extensive area of snow. During the day, when that snow melts, that moisture evaporates into the air. And then at night, as temperatures drop down below freezing, any of that moisture condenses out as fog. But because temperatures are below freezing, it is freezing fog, which means that moisture immediately deposits itself on any objects, like trees, and it makes for a beautiful sight. As the name implies, freezing fog is simply fog that forms when temperatures are below 32 degrees. But what a beautiful sight it makes, because the vapor that's in the air in the fog gets directly deposited on those below freezing objects as ice. So we totally skip the liquid phase of water and we go directly from vapor to ice, and that's called deposition. You know, those little tentacles of ice almost seem to grow as the hours go on, as more and more vapor gets deposited as ice. Hoarfrost can make the roadways and sidewalks slippery, but it sure looks great.
Okay, the next type of frost is called a glazed frost. This is where you have water up in the cloud that is above freezing temperatures that is forming precipitation. So that raindrop is going to fall through some warm air. Closer to the ground is going to hit a layer of air that is cold or below freezing. And the water drop is going to become super cooled, which means it's going to be below freezing temperatures. However, it's still going to remain a liquid because it typically doesn't have any solid particle to start the freezing process. So it's going to remain a liquid until it strikes something solid like a tree or something on the ground. Once the droplet hits the trees, it's going to start to warm up a little bit because that freezing process is going to release heat, and that's going to warm the water molecules up a little bit. It sounds a little kind of counterintuitive, but then it's going to allow the water droplet remain in a liquid state for a little bit longer. That's going to allow any gas or air molecules in the water droplet to escape. That's going to give it a nice crystal clear freeze on top of the tree.
This week's word is super cool. Super cooled raindrops, that is. They're cooler than ice. Yeah, they're that cool. Is the sticker still on these? I'm from meteorologist Jason Myers, and super cooled raindrops are tiny water droplets that remain unfrozen if undisturbed, even though they've been cooled to a temperature at or below the freezing point. So why aren't these water droplets freezing when they reach 0 degrees Celsius or 32 degrees Fahrenheit? Well, it's because tiny water droplets in their purest form floating around in the atmosphere won't freeze right at 0 degrees Celsius. Most of the time, they remain a liquid until one of two things happens. The water droplets find a speck of dirt, dust, or other tiny item on which to freeze, or the temperature drops to minus 40 degrees Celsius. This is why pilots have to look out for supercooled raindrops, because their aircraft may be that item the water freezes onto, causing icing and difficulties flying. Most clouds are made up of these supercooled water droplets, and freezing rain is falling supercooled raindrops that freeze on impact. What weather do you want to know about? Tell me about it in the comments below.
And last, you might often notice that frost is going to form on open ground, fields, or on your lawn before it would form underneath the tree. This is because the tree is actually giving off radiation, more radiation than the grass, preventing the frost from forming. Remember, all objects in which have a temperature are going to emit some form of radiation. This tree is emitting more radiation than the grass is.